Hi everyone. In this lesson, I'm going to demonstrate to you how to develop a game that I'm pretty sure that most of you were playing when they were kids. So now you have the awesome ability to create it by yourself. The game is called Brick Breaker, and I can show you how it works before creating it. So you have the pedal and you have the bow, and once the user interacts with arrows, the ball starts moving and breaks the bricks. The game is completed in Java frame, and if you can see that when we lose, you can see the message game over, and you can press the enter button to restart the game. And the whole game is created in only 3 files. It's a quite simple game to create, as in this version. So what we're going to do in the next sections is going to be developing the main class, which is going to work with JFrame. I'm going to explain to you what JFrame means later. To create the game logic, we will create the file gameplay, where all the data regarding the location of the ball and the location of the pedal is going to be implemented. This is also the longest class we're going to create, and it's about 220 lines. And after we do this, we'll take a look at the map generator, which is about 45 lines of code. In general, this whole game takes about less than 300 lines of code, and I'm going to go through the whole process of developing it. First thing we need to do is to create a new Java project. We can do this by selecting New, Project, and Java Project. Then the name of the game is going to be Brick Breaker, and that's it. Okay, let me close the solution. And now this is our project. Firstly, we're going to create the 3 classes I've already showed you. Let's create a new class. So this is going to be the main class, and for that reason we're going to select this option, public static void mean, and the mean method is going to be implemented here. Let's select finish. So this is our main method. Then we're going to create another class, and the name is going to be gameplay. Here we don't select this option because this is going to be a standard class for the gameplay. Press finish. One more class needs to be created, and this is going to be our map generator. Okay, press finish, and now we have all the files we need to create the game. Thank you very much for watching this video, and see you in the next one. Main class development. Here, the game window will be created. JFrame will be used to set the window bounds and its size. Here we go to the main class and let's write JFrame Here we create a new object from the class JFrame, and we need also to import the JFrame. Next, we're going to create the gameplay object. So the gameplay object is actually related to our gameplay class, and later on I'm going to make this statement active when I implement the gameplay class. But for now we need to add only this line. We are not going to use it until we develop the whole class. Now let's create the frame of the game. So we press Object, Set Boundaries, and here we're going to write the bounds of the game. It's going to be 10 on 10 on 700 on 60. You can also get a little bit further information about the setBounds method when you hover over the method name. And here you can see the X and the Y directions are 10 and 10, and then the width and the height of the frame is 700 and 600 respectively. Let's add a little bit more specifications to our frame. Okay, now we're gonna set a title. Brick breaker. Then we're going to make sure that our window is not resizable. So set resizable is going to be false. We're going to make our frame visible. And we're going to set the default close operation to be when we press the close button of the window. Exit on close. And our framework now should be ready to be displayed. So if I select to start the main file, now the frame of the game is displayed. There is no information yet displayed in the frame because we didn't develop the whole game, but at least we've got the window. You can also try to practice by playing with these parameters and see how our frame is going to be changed. This is a way to learn and to get into the detail of these methods related to the J-frame. Thank you very much for watching this video and see you in the next one. Bow and pedal display. In this lesson, the most important gameplay class will be started. I will show you how to add objects to the game window using the graphics method. We will go further by setting the control parameters for the bow and the pedal movement. Let's get started. Now we can extend the gameplay class. In order to be a panel, this class has to extend the JPanel method. We need to import it. And also we need to implement the we also need to implement the actions from the keyboard and also the movement of the ball. For that reason, we're going to add the key listener and the action listener classes. We get errors here because we need to import these packages. Now we're getting an error here, and this is because we need to implement the key-listener methods. So press here add unimplemented methods, and now we have added all methods we need. Now we can scroll up and start adding the values of our code. Okay, let's start. Firstly, we're going to add the boolean play, so we can control the game whether it's play true or play false. We will need a value of the scores. Which is going to be an integer. Then we can add the number of the total bricks. In our case, this is going to be 21. We will need to add timer and delay. Okay, so here we get an error because we need to implement the timer. The next values that we will need to add is the locations. The location of the pedal and the location of the bow. So let's do this. The position of the pedal is going to be 310 on our frame. The X location of the bow is going to be 120. I'm actually going to copy the private int part of the line so it's easier for me. Bow position Y is 350. The X direction is -1 and the Y direction of the bow is going to be -2. The X and the Y directions, I missed the minus here. The X and the Y directions of the bow are going to be the increment with which the program will know how to move the bow and which is the next location of the bow once the pedal hit it or it interacts with the wall. Let's now set a values for the gameplay initialization. So when we call a gameplay object, it is going to be initialized with the values I'm going to write now. We will add the key listener so we can use inputs from the keys on the keyboard. We just added the key listener. Now we will set the window to be focusable. The focus of the traverse keys will be false. Then let's initiate the timer. With delay of 8 seconds. There is an error here. The next step is to create the graphics method. In it, we will display the bow and we will display the pedal, and we will also control all the things that are displayed on our game. Here we use the graphics and we will need to import this package. So we remove these errors. And let's continue with the body. First, we will set the background of our game. In this line, we set the background color as white, and we will need to implement the color class. Then we will say what we want to be filled from our screen. You can actually imagine that the frame is a square that needs to be filled with different attributes, with the background, with the color of the bow, with the color of the bricks, and so on. So here we don't actually initiate what is going to be the functionality, but the colors and the positions of the different items displayed on the screen. Let's do fill rectangular, and here we will need to specify locations, width and height. The width is going to be 692 and the height 592. Let's set the borders of the screen. So here in a true rows, we'll set the position of the borders. Okay, the first border is going to be shown on 0, 0, width 3 and height 562. Six nine two is the width of the next border, and the height is 3. And finally, the top border is 691x y0. The width is going to be 3 and the height 592. You can see that the top and the bottom border are the ones that are on the left and on the right side of our screen, the ones that the game is going to be present on. So the height of the screen is 562, and from both sides we have borders, and the other border is with width 692, so it is on the top, and its height is 3. We'll see the borders on the screen in a second. Let's now set the attributes of the pedal. What color to put on the pedal? Let's make it blue. And then again fill rectangular. And here we'll actually do something different. Instead of specifying exact location of the pedal, we'll set the X location to be dependent on the variable player X. This is going to allow us to connect the value of the pedal to the arrows of the keyboard and then change it. And in that way, we will be able to move the pedal on the screen. And that's how we're ready with the pedal. Finally, we will add the bow and let's choose for the color of the bow green. And the initial location of the bow is going to be similarly to the pedal. With the bow, we would like it to move not only in X direction but also in Y direction. Let's write bow position X, bow position Y, and then the width and the height of the bow. Also, we actually here need to do not fill rectangular, but we need to make the bow to be a circle. So instead of fill rect, we will do fill oval. And that's how we have the bow. It is very important to mention that the bow positions are the ones defined in the beginning of this script. They correspond to bow position X and bow position Y. This means initially the bow will be displayed on 120 X and 350 Y. Thank you very much for watching this video and see you in the next one. Bow and pedal functionality. Here we will further develop the gameplay class. This video will answer the following questions. How do we connect the keyboard buttons to have impact on the pedal movement? how do we make the ball moving, and how do we make it bounces from the walls, and finally, how does the ball interacts with the pedal. The answers of all these questions will be shown to you in the next 20 minutes. Enjoy. As we have the graphics method, we have the ball, the pedal, and the background displayed. But now we need to add the functionality of that setup. This is done by the functions displayed here. What we want first is when we press the left arrow, our pedal to move left, and when we press the right arrow, our pedal to move right. Let's do this here. We'll do an if loop. What we wrote is if the argument in our code is the right key button, this function getKeyCode is actually getting the code of the right key. So simply here we check if the selected key is right arrow. And if this is correct, we will do another check. And this check is actually done to ensure that the pedal doesn't go further than the borders of our map. Here we say if the position exceeds 600, the X position exceeds 600, then the pedal is going to be displayed at position of 600. So we make sure that our pedal doesn't go further than 600 on our map. And if our position is lower than 600 and the right arrow is selected, we'll do what is going to happen then. Then we would like to move right. This is not built-in method. This method we will create later. And I will show you how, of course. For the right key button, we will do a similar thing. So let's copy the code we've already created. In the next case, if the key code equals to the right button, to the left button, sorry. And also, if the position Y is less than 10, then we would like the position Y to be equal to 10. We actually don't have the Y, but we have here the X position. Sorry for that, because we're moving only to left and right on the X axis. If this is not met and our X position is higher than 10, then what we would like to do is to move left. There you go. As I promised earlier, now I will create the move right and move left methods. Let's do it. Yes, I'm missing a bracket. That was on the wrong place. Now we have the move right method, and we will copy it to create the move left method. Move left. And here we want the play to be true and the movement to be minus 20. So these are the two methods, very simple. And here we had an error which I just fixed. Okay. Now let's check what we have so far. Oops, we have an error here. Let's see what could be it. I think I didn't fix the timer error yet. So let's do this. Also, if you remember the problem we had with the timer, the package we implemented was different. So the correct package we will need is this one. If you have a different package for the timer, we can change it to the one you can see on your screens. We would like to test the game at some point. Let's do that. First, we will need to go to the main class and add the gameplay to our object. Now we can continue with testing our code. I found a mistake here in the paint method. I wrote print instead of paint. Let's fix this. And also this value here should be 592. Then in the paint method, we need to add the dispose function to make sure that once this function is executed, the system will release the resources used for it. If we run our code now, we'll actually not be able to use the keys to move the pedal. In order to do this, we need to modify it we need to modify this method here, action performed, which basically says what is going to happen when we perform a certain action with the keys. Let's write here timer.start to start a timer of 8 nanoseconds and repaint method. The method repaint, after a certain amount of time, which is set by the timer, will automatically update our window. Let's run the application. Okay. And now we can see the yellow borders, the bow at the location we placed it, and the pedal. When we move the left and the right key of the keyboard, the pedal is moving. So now you can actually see that your effort makes something that you can play with. It's not ready yet, but you can see the framework of the game. The next step of our project is to enable the movement of the bow as well as the interaction between the bow and the pedal. I'm going to show this to you now. Let's perform an if loop, and we'll say if we play, this means the play value is true, and if we create a new rectangular object, we create a functional rectangular which has the x and the y position of the ball. Here's 20. And this will represent the functional ball as an object of interaction. The rectangular interacts with the pedal, so use here the interacts function. With new object, rectangular, and let me fix this, interacts. And on the right hand side we'll create another rectangular which will represent the functional volume of the pedal. Next, we will enable the ball to move in our game. We write ball position X and I'm copying this on the next row to save some time. Here we say that the position of the ball on X direction and Y direction is incremented by the bow X direction and bow Y direction parameters. And if you remember earlier, we stated that these parameters are -1 and -2. So you can imagine how the bow is moving with -1 and -2 points in each direction at each time, giving it a 2D movement. We need to create a loop that covers what happens when the ball touches the walls of our frame. We can do this with the following lines. In the first two if loops, we state that when the ball position is smaller than 0 at x-axis, we will change the sign of the direction. Let's say if our direction was -1, then we will change it to +1. This will create a bouncing effect from the ball, from the wall. And this is the same in the y direction. We would need only to make sure that we also bounce from the third wall, which has the x position of 670. The last if loop ensures that if the ball reaches the value of 670, it will bounce back and will change its direction to negative, or the sign of the x direction will be changed once again. It is actually a very good practice when you write this code to write the comments with it. This will make sure that once you go back to it, that you don't forget what line means what. So you can basically do this with this symbol and write your comment. Let's say I would like to write here a comment saying ball pedal interaction. So I know that these lines are related to the interaction between the pedal and the ball. Our code is almost ready. We just need to specify that once the ball interacts with the rectangular, it bounces back from it as well, like we previously discussed the case with the walls. So I actually didn't add that very properly, and now I'm going to fix these mistakes. Let's run the game now and see our result. Once we move the pedal, the ball starts moving as well, and then it interacts with the pedal. So you can actually see that the ball is moving with -1 and -2 on x and y directions. And imagine how the screen is constantly updating to show the movement. Thank you very much for watching this video and see you in the next one. Displaying bricks map. Once you have gained some practice with the gameplay class, we are now ready to display the map of the bricks. We will use nested loops to create the bricks. You will also learn and practice the graphics 2D method, the draw, and the fill methods. It is time now to update the map generator. Let's double click on this class. And here is the map generator class. Obviously, here we will set up our map. And let's start writing. As you can see, our map is going to be a two-dimensional array or matrix. We will set the brick width and brick height as well. And then we'll write our script that actually creates this two-dimensional array. In order to do this, we will need to use a for loop. I missed here the equal sign. Here in this for loop, we will develop an actual matrix, and the value of each cell of this matrix will be equal to 1. Later on, we will use each position in the matrix to create our bricks. The values I and j simply control the location of each cell. Let's say a cell can have a value I of 0 and value j of 0 as well, which means it will be in the left top corner of our matrix. But I will show you this in a second, because we will debug this code, and I will show you how actually the matrix is created. And here we define that the position that we're currently on has a value of 1. Let's set now the brick width and brick height. Is going to be equal to 540 divided by the columns, and the brick's height will be equal to 150 divided by the number of rows. Sorry. Once we have created here our bricks matrix, we will continue with creating the graphics. As you remember, we cannot draw our bricks without the graphics. So for now, we just set their positions on the map, and now we will use these positions in order to draw them. And here we'll use the graphics 3D method, which we'll need to implement in the class. And next we will create a for loop that we had earlier. Let's actually copy it. And then we will need to set the cover of each position on the map. So for each position, which is ij, that is higher than 0, we will need to set the cover and also to set the dimensions of each brick on these locations. Here we can choose the color of our bricks, and I would say let's make them black. Then we will fill them with the function that we already used for the bow and the pedal. It's fill rectangular, and we will add the location of each brick. The width is going to be brick width, and the height will be controlled by the value brick height. Oh, I got a spelling mistake, and I missed a curly bracket here. In order to display our map, we will need to call it from the gameplay class. Let's do some modifications here. Here we create a new object which is of a type map generator, and then we will also initialize the map generator in the gameplay method, and we will set the numbers of rows and the columns. So this is going to be map equals to new map generator with 3 columns and 7 rows. If you are thinking from where this is coming and how we can actually set 3 columns and 7 rows, this comes from here. So when we call our constructor, it requires first to state the rows and then the columns. And these values automatically are assigned to the rows and the columns displayed here in this method. We will also need to do some modifications in our graphics class. And this line here says to the program that the map has to be displayed. Let's see the error here. We will need to import the 2D graphics. Have a look. So you can see our map is drawn, and we will soon be able to divide it on different bricks. Now I would like to take a step back here and show you how our map is actually generated. So we'll do this by debugging our map generator code. Let's double click on this line here and start the debugger. But before that, let's also display the variables. You can see them here. Single click, and you can nicely place it on this side of your screen. And then let's debug it. Now the program is just about to execute this line, and as you can see, we already have 3 rows and 7 columns, and we have our map. As you can see, every value of our map equals 0. So we have a map again of 3 rows and 7 columns, which is a 2D map or matrix. And now we start to go forward with the code. You can see how the values of I and j are moving. So once j6 is reached, the value of I is changed to 1. And what happens with our map? It gets a values of 1 for each position. And this will continue. And if we go forward, you will see how a different instance of I and j is created, and our map is filled with ones everywhere. And this is how the map is created. Let's close this window and continue with writing our code. Let's make sure now that our bricks are divided. We can do this by the setStroke function. Once we did the stroke, we will need to figure out what is going to be the color of the stroke. So the stroke is actually the lines between each brick. Let's do them white, so they match with the background color. So we'll do again set color white, and then we will draw these lines. Here we get an error. This is because we need to import the basic stroke method. There we go. Also, I thought that you might be interested on why we add the values of 80 and 50 here. I'm going to show you this right now, but let's display our map first, right? So the value of 80 and 50 is essentially the value from the wow. Okay, so if I can move this down a little bit, we can see here the value of 80 is the one between this wall and the brick. Okay, so what our code is doing is it is saying, okay, create the first brick on J, which is 0, multiplied by the brick width, so this here is 0, and then add 80. So the first brick is actually going to be displayed only on distance 80 from the wall. Imagine when you create the next brick, I is still going to be equal to 0, so we don't look at the next row. Here the distance is 80. Then we add 1 multiplied by the brick width, which means that we cross this brick, and then we display the next one here. And this process is working for the whole bricks. For the third one, it is going to be 2 times the brick width plus 80, right? For the brick height, it's a similar thing. We just do this in the y direction. So from the top to the bottom, 50 plus the brick height, and that's how we draw all the bricks on the map. And you can see now when we move the pedal and the bow is moving, but we still cannot interact with the bricks. This is because we will need to implement the interact function in that case. Thank you very much for watching this video, and see you in the next one. Bricks functionality. In this video, we will add some functionality to the bricks, so the exact brick disappears once the ball hits it. This is a challenging task, and we use a combination of loops and statements to complete it. We will need to add another method in our map generator, public void set brick value. And we do map row column equals value. I get error here. I think this is because I didn't match the curly braces. Yes, this was the reason. So this curly brace closes the graphics 2D method. So of course I will need to write this method outside this. And now we are ready with our map generator class. Let's save it. And the next thing we'll need to do is to enable our bow to interact with the bricks. We already done a similar thing when enabling the pedal to interact with the bow. We can do this in our gameplay class, modifying the action performed. You probably noticed that all actions that are happening on our game are added here in the action performed. So this method is very important and it can be used for a variety of games and it really simplifies the things. Okay, that's right. Here we write the for loops for assessing our map locations or our bricks. Maybe you notice that I wrote map.map.length, and the reason for this is because firstly we have the map variable here, which is our matrix, and the next we have our map created here. So this means the object map has an attribute map, which is our matrix, and this attribute map has its length. Okay, the object map has attribute map, which is matrix, and this matrix has length. Let's do if map.map ij, which means for each location on the map that is higher than 0, we'll create locations of the bricks. Brick x equals j multiplied by map dot brick width plus 80. So it has distance of 80 from the map. Whoa. Brick wide will be equal to I multiplied by map dot brick height plus 50, the distance from the top wall. The width is going to be equal to map dot brick width, and the brick height will be map dot brick height. What we are doing here is that we're just assessing the brick width and height from our map generator class assigned to the object map. So if I hover over here, you can see map equals 0. This means that the map keyword represents the object generated here. This is not our matrix. So when I do map dot, I assess the attributes for the map object from the map generator class. So if this map is the highest level, under it on the same level there the matrix that is called map, the brick width, which is the width of each brick, and the brick height. We will again recreate a rectangular for the brick, for each brick, and for the bow. So when this loop is executed, we can control the values of the bricks and on the bow. Let's create now the bow rectangular. Equals new. So what we simply do here, we make an imaginary rectangular over each brick, and we make imaginary rectangular over each bow, or actually the only bow that we have. So we make it over our bow. Let's do one more object. So this is the brick rectangular will be equal to the rectangular, so to this line here. Now when we have our objects, let's start to control them, and let's make them actually interact with each other. So when we do bow rect dot intersects with brick rectangular, and here we say what would happen if the bow interacts with the brick. Bear in mind that here we're still in the for loop. This means that the bow can interact, we check if the bow interacts only with one of the bricks that is currently in this for loop. So if the bow actually interacts with the brick, we'll do the following actions. We'll set the number of the columns and the rows to the values of I and j. And this method is the one that we called in the map generator, if you remember. So that will make, in our matrix, if you remember, that was created only with ones on each location, that will make the current location of the matrix to be equal back to 0, which will actually remove the brick. Now we will reduce the number of total bricks. And we will increase the score. Now the ball can interact with the bricks. However, in that case, if we run now the game, we'll see that the ball will go through the bricks and not bounce from them, because we didn't set this functionality yet. Let's do this with an if loop. So if the ball position on x axis plus 19 is lower or equal than the brick rectangular dot x axis, or ball position x plus 1 is lower or equal to brick rectangular dot x location. So this is the x location of the brick rectangular plus the brick rectangular dot. So this is the width of the rectangular. And if so, then we would like the bow x direction to be reversed. And else, if this is not valid, then we would like the y direction of the ball to be reverted. And we've got a few errors here. Let's check what is with them. Okay, we need to initialize this value of I. For that reason, we'll go there. Here should be j, not I, of course. That should work now. Let's have a look. Now, as you can see, the bow is actually breaking the bricks, and it also interacts with the pedal. Thank you very much for watching this video, and see you in the next one. Game restarting and score display. Congratulations, you completed most of the game. But have you ever asked yourself how the game knows when you won? Or how the game knows when it's game over? I will show you this in this video. We will also look at how to display the score and how to restart the game using the Enter key. So let's get to work. Let's add our scores, and also let's enable the game to display whether we won the game or we failed the game and it's game over. Let's enable the player to see his score on the screen of the game. So let's do g dot set cover dot. So they are going to be in black. Okay, and it's very important to say that we do this in our paint graphics method in the gameplay class. We do g dot set font new font, and the font is quite cool method that we can set the type of font. We can make the font bold, which I'm going to do right now, and also the size. I already added the font here, so if you get an error, you should be aware that could be because of that. So please import this method in here. Let's go back to our graphics. And here we don't want only to write the score, but we also want to update it. And this is done actually quite simple by drawString function. So the drawString function has three values that has to be added. The first one is a string, any string. In this case, we use score, which is a value that has constantly updated when we break the bricks, if you remember here. So after we break each brick, the score value will be updated and displayed. And after that, we will simply display the location. So we set the location of where we would like to see our score displayed. And that's it. That's it with the score. Let's continue with displaying the game over message if the ball did not bounce from the pedal. So let's do this as an if loop, and we will say that if the ball position Y is higher than 570, this means that it went under our bottom border. We will change certain values when this happens. So we will change the play value to false, so the game will stop. We will change the x direction of the ball to 0. We will change the y direction of the ball to 0. And we would like also to add the game over message. Here I have it done already. It's quite similar to the score message. What is changed here is location of where the message is displayed and the fonts, and of course the type of the message. So first we say game over and we display the score. I will actually add here the score. So we have the score displayed. And also I would like this to be displayed in red. Let's also create a similar message for when the user wins the game. Let's do it here. And we'll say that if the total number of bricks is less than 0, I'm going to copy these lines here so we save some time. So when this happens, we want play to be false, the ball x direction 0, ball y direction 0. I would actually like the color to be green in that case to give us some positive impression. I will write here U1, U1, and we'll keep the score. And this message I will keep as it is because I would like, if the user wins the game, so he's able to restart the game again. Let's run our code now and see what happens. Okay, first I will wait until the ball fails and we'll get the game over, the score of 15, and press enter to restart. I notice here that I need to remove this. Once we did this, we can test our game now and check whether the messages are displayed as we would like to. Okay, we get the game over and we get the score. And if you notice, when I move the arrows, the pedal is still moving. And when I press the enter, nothing happens because we didn't add yet the enter functionality. Let's do this right now. You are aware that we can add the enter functionality in here in the key press section. It is very important to note that when we press enter, we want a few values to be updated, so everything can start from the beginning. So we'll do a similar thing. So here we say that if the enter key is pressed, and if the play is false, then we would like to say the play to throw back again. Also, we want to update the X and the Y position of the ball. I will also update the ball X and Y directions. We want our score to be equal back to 0 again, and the total number of bricks to be displayed. We will also update the map generator. And don't forget about the repaint function, because with it we will repaint the map back to the initial state of the game. Let's test it now. I move the left and the right arrows. The ball starts moving. Let's leave the ball to fail. And let's press enter. The game starts back again. And as you can see, when we won, we see the message in green. And when I press enter again, the game starts from the beginning. Well, thank you very much for watching this video from the course. I hope you enjoy playing this game that you just developed by yourself, and I'm looking forward to see you in the next section. Thank you very much for watching this video, and see you in the next one.